Okay, section 1.3, graphs of functions. To start with, we're going to talk about increasing, decreasing, and constant. So a graph is considered to be increasing if, as we trace from left to right, the y values are getting bigger. The easy way to think about this is as you trace from left to right, that's the way we read, right? From left to right, the y values are getting bigger or it's going uphill. So if this red mark is my finger tracing this from left to right, the arrows are going uphill and until it hits the peak. So from way down here, which was negative infinity, until it hits the peak at, notice it's an x value of 2. I understand the peak is at 3, but these are domains. It's x values. So this graph is said to be increasing from negative infinity until 2. Notice that they're parentheses. We always use parentheses. I'm just going to write a parentheses. I never remember how to spell parentheses. It's always parentheses for increasing and decreasing. So as it approaches from left, the graph is increasing. The y values are getting bigger as we get closer and closer to the vertex, which has an x value of 2, which is why it's from negative infinity to 2. So that was our increasing. Let's highlight the word instead. For decreasing, as we trace still from left to right, the y values are getting smaller, or an easier way to think of that is it's going downhill. Again, if we pick up where we left off, since it's the same graph, right? It was increasing to 2, but then if I keep going with my finger, which I'm now using purple arrows to represent, it's going downhill. So it is decreasing. I don't know if this is on your paper. Oh, it's on the side. Okay, found it. It is decreasing from 2, a parentheses again, and it keeps decreasing forever, so all the way to infinity, remembering that this is a domain and it's x values. And we always use parentheses for increasing and decreasing. Then we have constant. Constant as we trace from left to right, because that's the way we read, the y values are remaining constant, not changing. Think of this as being flat. So if you look at our graph, pretty easy to see the flat spots. It's constant, it's flat, x values from 1 until 4, and notice this one, we use brackets. So from 1 to 4, it's flat, so it's constant. The domain is bracket 1, comma, bracket 4. Okay, next is even, odd, and neither. A function is even if when you plug in negative x, then you end up equaling the original function. So let's put this in words. Plug in negative x. You simplify it, and you get original function. It didn't change anything when you plug in negative x. So there's an example here. They plug negative x into this equation, x squared minus 5. They do the simplifying, and you get back out x squared minus 5. You get the exact same equation back out. Nothing changed when you plugged in negative x. That's how you check algebraically to see if a function is even. It's also helpful to remember how you can check visually. If you have a graph, for example, well, let's just do this one, right? X squared minus 5. So it had a vertex at negative 5. It's a parabola. It looks like this. The reason this is even, the reason I can tell quickly this is even, is that if I fold it on the y-axis, it lands on itself. Each point perfectly lands on another point. This point here, when I fold it, would land on this point here. This point here, when I fold it on the y-axis, would land on that point there. So you can tell visually just by imagining folding it on the y-axis. For odd functions, it's the same test. So you're not testing anything different. You're still plugging in negative x, but you get the totally opposite function, negative f of x. So we still plug in negative x, but you get opposite the original. So that negative sign is shot all the way through it. So again, there's an example. They plugged in negative x to a new equation. We're using this equation now. They did the simplifying, and you end up getting the complete opposite of the original. If you factor out that negative sign, you see that it's the opposite of the original. That's how you know something is odd. Graphically, if I have a graph, I'm not going to do that exact one. I'm just going to do a different one. Maybe it's a cubic or even a tangent because it's hard to tell. If we have a graph like this, the way you can check and see something is odd is if you flip it upside down or rotate it 180 degrees, which if you have your paper in front of you, you'd be looking at your paper upside down. It's still identical to the original. So if you've sketched this on your paper, go ahead and spin your paper so it's upside down. You're looking at it 180 degrees upside down. If you still compare it to mine, it should look identical to mine. And then if you plug in negative x and you just get some crazy answer, it's not exactly the same and it's not exactly opposite, then we say it's neither, right? You need to have a third option. Not everything is even or odd. Sometimes the answer is neither. Pretty straightforward. Okay, next is relative extrema. So we have relative minimum and relative maximum. A relative minimum is the value of a function. So if you've got a graph and you've got a little dip in your graph, and it can be doing all sorts of other things, but right here there's a dip in the graph, that's a relative minimum. Whereas a relative maximum is the peak of a function. So relative maximum might be an upside down part of a parabola. Right here is the relative maximum because compared to the points around it, it's at the peak. It's not the complete minimum or complete maximum. It's relative because it's relative to the points around it. Remember, these answers are points, so they should be written as points, and we have an example done here. So I want to do a lot of stuff to this example. So we'll talk about the answers that are already written there, and then we're also going to fill in some answer blanks that you'll be expected to fill in on a lot of tests that we do. So there's a graph, relative max. So let's see where those came from. So relative maximum is the peak. So if you look at the graph, right here is a peak, and right here is a peak. So that's where those points came from. Maximums are points. Relative minimum, also a point. The bottom of a valley, right here was the bottom of a valley. Hopefully you can just see those and answer those. But we're also going to ask for increasing, decreasing, constant, even, odd, neither, domain, and range. Okay, so if we look at this from left to right, I start at the furthest left because we read from left to right, and I start tracing this with my fingers, which I'm using a pink arrow for. Are the pink arrows going uphill or downhill? Well, they're going uphill, so they're increasing. Remember, increasing, these are domains, and we always use parentheses. So I'm going to start a parentheses. My pink arrow started at negative infinity, comma, and it increases to the top of the hill. But it's domain, so it's at the x value of -6, parentheses. Then, from there, it's going to start going downhill. So, tracing it with my fingers, it's decreasing because it's going downhill. So, decreasing from -6, and it decreases until, remember, it's domain, so x value, -3. I keep tracing it with my finger. It's going uphill again, so it has started to increase again. So back next to my -6, it's increasing from -3 until when? Well, it's an x value, so until 0, parentheses, always parentheses. Then it starts decreasing again, and this time it decreases for the rest of the time. So from 0 until infinity, it's decreasing. This is how we answer increasing, decreasing. It's never constant. So DNE for does not exist. Get used to using does not exist for things. Even, odd, neither. Well, I don't have the equation, but remember I told you how to look at it visually. If I fold it on the y-axis, they're not going to line up. And if you flip your paper over, it's going to look totally different. So this is N for neither. Domain and range. The domain goes left and right forever because there's arrows on it going left and right forever. So all real numbers. Range, it goes down forever, right? The down arrow. So parentheses, negative infinity. And it looks like it only goes up to this highest point right here. And range is y values, so 5. It touches that, so that's a bracket. So you can expect to have to answer all of these little things, all these little answer blanks on the test. So make sure you understand the differences. Okay, for our examples, I have to give you the graphs ahead of time. So in a later chapter, we'll teach you how to get the graphs yourself. But for now, take a second and copy down the graph that I've given you. That matches the equation given, by the way. And then I will write down all the answer blanks of what we're going to find. Pause it to copy down the graph. We're going to find domain, range, increasing, decreasing, constant. Even, odd, neither, min, and max. I'm going to go over here. Relative min is what I should say, and relative max. Okay, so hopefully you've got your graph copied down. This is grabbed from Desmos, and when your teachers snip something from Desmos, this right here, the end being flat, it's implied that there's an arrow at the end of that, and there's an arrow at the end of that. It's a screen capture, right? The graph has to stop somewhere when I take a screenshot, so there are arrows at the end of those. So for domain and range, the domain, those arrows are going left and right forever, so domain is all real numbers. For range, there's an arrow going down and an arrow going up forever, so that is all real numbers as well. You have 2 points. Figure out which one's a min and which one's a max, relative min and relative max. So bottom of a valley is your relative minimum. Notice it's rounded to 3 decimal points. And top of a hill or peak is a relative max. Also 3 decimal points. Okay, so then increasing, decreasing, constant. Start from left, the furthest left. We read from left to right. And as you're tracing, you are going uphill. So increasing from negative infinity until you hit what? When does the graph stop increasing? Remember, it is a domain, so it's at the x value of negative 1.638. Then it starts to go downhill, so it is decreasing from negative 1.638 until when? Well, until it hits this relative minimum at 0.305 because it's an x value. Then it starts increasing again from that same x value. And this time it increases for the rest of its life, so till infinity. Increasing, decreasing is domain, and it's using parentheses. Constant, where is this graph flat? It is not flat, does not exist. And then even, odd, neither. You could plug in negative x and see if you get the same equation or the opposite equation. Or you can look at the graph. If I fold it, it's not going to line up. And if I flip it over, it's not going to match perfectly. Because this point is now going to be up here, and it's not going to match. So this is N for neither. I'm just going to circle the N. Okay, once again, I have to give you the graph. There is your graph for number 2. Pause it and copy down the graph. I'll write down the answer blanks. Okay, and then this time, see if you can do these on your own. Pause the video. When you unpause it, I'm going to have all my answers on the screen. So see if you can finish this one on your own. Okay, there are all my answers. Check them with yours. Pause the video if you need to check them and write them down. Okay, last one is a piecewise. I do want to go through and teach this to you. So piecewise, in this example, it's 3 pieces of 3 different graphs that give us our function f. So let's make a pretty good sketch of this. We're going to need these numbers. And what I'm going to do is one piece at a time. So x plus 6. So our equation is x plus 6. But the x values that it wants me to use, it says only the x is less than -3. So we are going to start at -3. But then we're going to go down, right? Less than, -4, -5. That should be enough. Plug in -3. And these are going to be our answers. But because the less than symbol does not have an equal to bar, we're going to make our first dot hollow. This is going to be a hollow dot. So at -3, I have graph paper, so I'm just using the graph paper. +3, it's an open circle. But the rest of them are regular dots. -4, 2, -5, 1. You can kind of see what's happening here, plus you know it's a line. So you only want a piece of the line that is less than -3. Then we go to the next piece of the graph, this one. This one says the answer's 3, but only for x's from -3 to 1. And the answer is going to be 3 for all of it. It's literally telling me the answer. The first one is solid because it has an equal to bar. That's going to be solid. So -3 is going to be solid. But then the last one doesn't have the equal to bar. That's going to be hollow. So this one's going to be hollow. So -3, 3 happens to land right on top of my other graph. And now I'm filling it in because it said that dot's supposed to be solid. And then 1, 3 is supposed to be hollow. And then the answer's 3 for everyone else. So it's a straight line going sideways. Piece of a line. The last piece of this function is x minus 3. This should be enough room. X minus 3 squared minus 1. But only for all the x's bigger or equal to 1. So 1, 2, 3. Plug in 1. That's -2. Squared is 4. Minus 1 is 3. That's -1. Squared is 1. Minus 1 is 0. That's 0 squared minus 1 is -1. So but then we need to look at the symbol. It has the equal to bar, so it's solid. At 1, 3, it happens to land on itself again. This is very rare, but there's a solid dot now at 1, 3, 2, 0. Oops, 2, 0 was a point. 3, -1 is a point. That's not really looking like a parabola yet. We should probably plug in 4. That's 1, 1 squared is 1, minus 1 is 0. Now we can see how it's going to look like a parabola. The next point's going to be here. So it's a piece of a parabola, not the entire thing. This is our piecewise function. Now we need to find all the same answer blanks as before. So I'm going to need some space. Domain, range, increasing, decreasing, neither. Even, odd, neither, and the relative mins and max. Okay, domain, they happen to touch, so this graph, I could have drawn this graph in one big, thick color. The whole graph goes down here, touches that point, then it goes over, touches that point, and then it comes down and over. So there are no gaps in this graph. And there's arrows on both ends, so the domain is all real and the range is all real. increasing, decreasing. Well, let's just look at the graph, right? From left to right. From left, it is increasing until it hits that point. So from negative infinity until, which number do I put there? It's the x value, so negative 3. Then this is our first one where it's flat. It is flat. I'm sorry, I wrote neither. It was supposed to be constant. You guys paying attention? Did you write that down as constant on your paper? Good job. So after it's increasing, it is constant from that spot. And remember, for constant, we use brackets. From negative 3 until when? Until the x value of 1. Then if I keep tracing it, it's decreasing. So decreasing, parentheses, from 1 until it hits that value is 3. And then it's increasing again from 3 to infinity. Relative min and max, even odd, neither. You can't fold this, you can't flip it over, neither. Relative minimum right here at 3, negative 1. And then finally, relative max. Remember, relative max look like the top of a hill or the peak of a hill. And since this is flat, right, that's not a hill, it is not a relative max. The relative max does not exist. Okay, that is it for this section. I hope you guys are doing good.